Okay, this is mole worksheet 3, some mole to gram to molecule conversions. This takes a couple of pages. I'll show you the first page here, and on the next screencast we'll continue. All of the following questions are based on lighting butane on fire, for which we can write the following balanced chemical equation. There's your butane, there's your oxygen, there's your carbon dioxide, and water. Convince yourself that 2 to 13 to 8 to 10 works. I usually pick the hardest one and see if it's balanced as a quick check, which I think is oxygen. See how it's on 3 of the 4 substances. Can you see how there's 26 oxygens on the reactant side? 16 plus 10 is 26 oxygens on the product side. This is balanced, at least for oxygen. Note the molar ratio of 2 to 13 to 18 to 10 to 8 to 10. In the world of stoichiometry, we consider these all to be equivalent. 2 moles of butane is equivalent to 13 moles of oxygen is equivalent to 8 moles of carbon dioxide, etc. Each example uses these conversion factors. The easiest are the one-step mole-to-mole conversions. Here's a sample question. How many moles of oxygen do you need to make 8 moles of water? To do these systematically in each case. I mean, there is a way to do it in your head, and I'll show it briefly, but I think at this state it's best to just show the systematic way of doing it. Now you start with what you're given, 8 moles of water. There it is. We recognize that since it says moles to moles, that's a one-step conversion, so draw a line. And it's a good idea to say where you're going, to moles of oxygen, so put that there. And then just use the numbers in front to do your conversions, and don't get it upside down. If you have moles of water there, put moles of water on the bottom so that it cancels, and then go to where you're converting to and use the number in front, and you should be good to go. Mathematically, that's the same as saying that 10 moles of water is mathematically equivalent to 13 moles of oxygen, and similarly 10 moles of water is produced for every 13 moles of oxygen that are reacted. Punch it in and you get 10.4 moles of oxygen. Fine. Now here's one for you. How many moles of oxygen? That's our answer. We're going to equals blank moles of oxygen are required to produce 240 moles of water. That's what you're given. So let's start with that. 240 moles of water times blah blah blah. You can do this in your head if you want. You should see that there's a 1.3 to 1 ratio, just like in the previous example, and boom, you do that fast and there's your answer. If that's not working for you, no worries. Start with what you're given, the 240 moles of water. Recognize it's one step, mole to mole, and then convert. Moles of H2O, we better put it down there. Every 10 moles of H2O are produced for every 13 moles of oxygen that react. Same answer, 312 moles of oxygen. Another problem. How many moles of butane are needed to produce 25 moles of water? That's what you're given. That's what you start with. That's where you're going, equals blank moles of butane. Since it is moles to moles, that's a one-stepper. You could try it in your head, recognizing that the ratio is 1 to 5, and the answer is 5. If you see that already, good for you. If you don't, do it the stepwise, reliable method. 25 moles of water produced, where every 10 moles of water that are produced require 2 moles of butane. Notice the mathematical cancellations. And we will require 5 moles of butane for the reaction. Type 2 means it's mole to gram or gram to mole type problems. They're two-steppers. You see them quite a bit. Here's a sample problem. How many grams of oxygen do you need to make 9 moles of carbon dioxide for this chemical reaction? Okay, start with what you're given, the 9 moles of carbon dioxide. Mole to grams, 2 steps. Boom and boom. Moles of carbon dioxide, moles of carbon dioxide. Numbers in front. 8 moles of carbon dioxide produced requires 13 moles of oxygen reacted. What does it weigh? That's the difference. It's like mole to mole, and then what does it weigh? Well, it weighs 468 grams of oxygen when you punch it through. Another one, and our last one. How many grams of carbon dioxide will be produced from 17 moles of oxygen? That's what you're given. It's a mole to gram problem. That's 2 steps. You're going to grams of carbon dioxide, and your setup would look like that, and then you convert. Moles of oxygen, well, every 13 moles of oxygen, there it is, will produce 8 moles of carbon dioxide. What's it weigh? 44 grams per mole. Punch it in. This reaction will produce 460 grams of carbon dioxide. Oh, there's one more. How many moles of butane are required to produce 100 grams of carbon dioxide? I see moles and grams again. I'm seeing a two-step process, which we've been doing here. I better start with what I'm given, this 100 grams of carbon dioxide. I better go to the moles of butane that are required for this chemical reaction, since carbon dioxide is a product and butane is a reactant. Okay, every 44 grams of carbon dioxide is a mole, but every 8 moles of carbon dioxide, once again the numbers in front, only require 2 moles of butane, making it a relatively small number, 0.568 moles of butane. This is mole worksheet 3, mole to gram to molecule conversions, part 1.